Hello and welcome to today's webinar, SigmaNEST for bevel cutting in organization of IB-CADDY and SigmaTech company. My name is Oliver Marinkovic from IB-CADDY, and with me is Diego Bartolucci, Technical Director at SigmaNEST. Today's webinar will start with short introduction of IB-CADDY company, and then we will continue with introduction of SigmaNEST. In the practical presentation, Diego will show basic steps of SigmaNEST from part import with bevel information, defining bevel rules, and generating toolpath. IB-CADDY was founded in 1991. Today it's present on 3 locations, of which 2 of them are in Slovenia, with the headquarters in Ljubljana and in Kamnik, where we have our Educational Technology Center. We also have office in the capital city of Serbia, Belgrade. We provide software solutions in different areas of industry, in the field for graphic engineering, 3D printing, and 3D scanning. One of the solutions we will present today is SigmaNEST. SigmaNEST is an advanced nesting solution, which offers a wide range of customizable modular features to get the most out of your manufacturing operation. Using SigmaNEST, you can import parts from any major CAD system, automatically sort them into tasks by material machine, optimize your material usage and machine motion, post programs to your profile cutting machine, and track your productivity from start to finish. SigmaNEST drives nearly every type of profile cutting, routing, or punching machines to produce premium quality parts while saving valuable material manpower. CAD integration, an intuitive interface, and local customer support are all reasons why SigmaNEST is the industry leader with over 21,000 systems installed worldwide. Here we can see some of the machines types such as laser, plasma, and oxygen machine. Also, we support programming water jet machines and punch and laser combo machines, or only punching machines where we can advantage of the tool start. Additionally, we also support knife machines and single or multiple spindle machines for cutting wood or composites. With SigmaNEST, you can also create nesting for any kind of the machine. The advantage of SigmaNEST is that we have one environment where we can program any of the mentioned machine type, and we are not limited to the machine brand. Also, if we create a task for one machine with a few clicks, we can change the NC export for other machines from your list. SigmaNEST connects individual manufacturing operations to the entire organization to drive incremental improvements and improve efficiency regardless of your industry sector. From quoting to production to shipping, SigmaNEST comes packed with a range of features that delivers 5K benefits to your fabrication workflow, also known as 5M. For materials, better nesting and improved remnant strategy that delivers 5% or more in material gains. For motion, our solution provides more than 20% boost in efficiency due to faster programming and faster cutting paths and shop floor solutions. For manpower, SigmaNEST increases manpower capability with ergonomic solution, industry-focused software, and process automation. In management, our solution integrates data from all areas of operation, giving you key insights and greater yields from your machine. Lastly, SigmaNEST allows you to run all of your machines from one software platform, allowing you to share skills through the factory, therefore increasing flexibility and efficiency. For many employing nesting software, the process to produce a quality beveled part evolves from days of even weeks of trial and error. Despite wasted time and high scrap rate, the part is still likely to require extensive manual cleanup. Bevels are edge cuts typically used to prepare steel plate parts for welding. Professional fabricators have long relied on CNC machines and nesting software to fine-tune and automate the beveling process. From design to production, SigmaNEST makes the beveling process intuitive. As your parts are nested, beveled edges are taken into consideration automatically, and nests are optimized around the cutting tolerance required to produce accurate edge bevels. In addition to automatic bevel transitions, SigmaNEST gives visual update to allow operator to double check quality in real time. In the next slides, we can see what kind of bevels we can program with SigmaNEST. The top and bottom bevels are the simple kind of bevels. They are produced by tilting the head and cutting the part's edge. They can be positive or negative, and because of their shape, they are also known as bevels. It is possible to combine a simple bevel with a straight cut on the same edge. This produces a land bevel, also known as epsilon bevel. The bevel part can be at the top or at the bottom. This kind of bevel requires passing 2 times on the same edge, once for straight cut and once for the tilted cut. In SigmaNEST, we can also program advanced bevels. Some advanced bevel options include the X bevel, obtained by mixing a positive and a negative V bevel on the same edge. The K bevel, similar to the X, but with an additional straight portion for a total of 3 cuts on the same edge. And the variable bevel, when the angle value changes while cutting the same border. In the practical presentation, Diego will show which options we have to import a 3D or a 2D CAD file. For example, we will import a simple SolidWorks file on which we have different kind of bevels. On the top, we will have a top bevel with different angles on different edges. On the bottom edge, we have a partial bevel, and in the middle of the part, another circular bevel. Importing a 3D model to SigmaNEST has the importing advantage that the SigmaNEST can read the bevel information automatically, and we don't need to spend time defining the bevels again in SigmaNEST. Also, if we don't have options to create our parts in 3D, we can use DraftSight or AutoCAD to create a 2D CAD file. In this case, we can group the lines and nodes to a string that SigmaNEST can recognize on import, and so this way the bevels informations are imported and the part is ready for programming. In our example, some of the lines of the part are grouped with the text V45. The bevel mapping table defines V as a top land bevel. So in this case, the 2 lines grouped with the V45 text have a 45 degrees top land bevel applied to the lines when imported into SigmaNEST. You can specify more than 1 string tag for each bevel parameter type. In case that bevels cannot be predefined, in SigmaNEST we have the options to define the bevel for the imported part. These options can be used if we import a 2D file that has no strings attached, or we create the part in SigmaNEST with CAD model. In this case, on one or multiple edges, we can define different types of bevels, as we can see from the bevel options. In SigmaNEST 20, we have a new functionality called a 3D view. These options allow us to have a look at 2D parts in 3D environment. We can check simple parts that need to be cut or a complex part with bevel information for a better presentation and understanding of the toolpath. Before we start programming our part with bevel, we will have a look at some predefined rules. In Rule Manager, we can create rules for corner loops, how the part will be cut. We can define different rules for the same type of corner. For example, we can have 2 rules for a 90 degrees corner where we can cut in triangle to switch from one edge to another, or we can define only 90 degrees turn from one edge to another. When we have the part and the rules defined, now we can program the path to cut the part. This means that in 3D, besides the 3D model, we will also see the toolpath based on the geometry and the loop rules. This also means that we can modify any step on any edge to our desired capabilities of the machine. We will see the simulation and how we can change the corner rules. Also, we will see how can we add the tabs to our part. 3D view programming also gives us information about the tool tilting, which means that we have the ability to control the head position on the machine on any of the edges of the part. We can also modify the lead in and lead out of the part of the path which will be a good example on the circle bevel in the middle of the part. At the end of the practical presentation, Diego will show us how we can nest our part. The focus on the nesting will be on the part-to-part distance, where the bevel informations are taken into account so that we don't have any overlap between parts. Since this is a complex part and we also would like to see the tilting tool on the cut path on our sheet, we will see how we can use the 3D view to check the tool simulation. So Diego, please, if you can share your screen and show us the mentioned workflow.
Yes, hello everybody. Oliver, thanks for your introduction. I will quickly share my screen. Okay. As you explained, today we will talk about the 3D technology in SigmaNEST with a specific focus on our bevel features, which got recently improved with SigmaNEST version 20. After the presentation, I will be available to reply your questions. So if you have any, please write them down in the chat. Okay, I guess we can start at this point. So in the first chapter, as Oliver mentioned, I will show you how to import geometries which contains bevel properties. As you can see here, SigmaNEST supports several formats and we can import the bevel information for them. For instance, we can import bevel properties from SolidWorks. This part, as you can see, contains several bevel edges. I'm going to close it now. And I'm going to import it in SigmaNEST. SigmaNEST will now contact SolidWorks and get it flattening the part and import it along with its bevel informations, which you can see displayed with these orange balloons. Of course, the same feature is also available for the other 3D CAD systems we support, as well as for the open 3D CAD formats. I can quickly show you the same part drawn as an open format step file. As you can see, I can use the same interface to get the same part and the same bevel properties imported as well. Of course, in case you don't have any 3D CAD, but you still want to set your bevel properties right in the CAD file, SigmaNEST can import them from DXFs or DWGs, for instance. It is enough to create strings representing the bevel types and the values, like I did here, and then group them with the entities. SigmaNEST will proceed to importing them smoothly. During the second chapter of this webinar, I will show you how to define bevels right in SigmaNEST. Though it is great to define bevel properties right in the CAD files, SigmaNEST also allows you to set the same properties from its interface. Let's use this part we imported from a DWG as an example. I can get to part mode, and I can use the bevel commands to, for instance, either change the existing bevels or add new ones. So let's look as an example. I will select all these edges, and I will change all of them to, let's say, a bevel 30. Additionally, I will use the same feature to set a new bevel property on this hole. Let's make it a Y positive bevel, like this. The other interface options allows you to change all the same bevels at once, to delete them, or to move their balloons. The part can then be saved to the parts library for later usages, and it can be added to a new work order as well. The third chapter of the webinar will show you a great new addition we presented with SigmaNEST 20 called View 3D. The 3D view is a new feature which does not require any configuration and which is available for all of our customers using SigmaNEST V20. This function is accessible from all the SigmaNEST packages from Light to PowerPack. When we click on the new View 3D button, SigmaNEST extrudes the part and transforms it into a real 3D object. This allows the user to see the real 3D design of the part, even if they didn't create it from a 3D solid CAD system. Also, newly for SigmaNEST, from this dialog, it is possible to export the part as a step file. This allows to import it into a 3D CAD and modify it later on. Now, since the 3D view is something new for several SigmaNEST users, I'd like to take a minute to explain how to navigate through it. First of all, the interface is pretty similar to SigmaNEST. We have the ribbon bar on the top, the tree view on the left, the status bar at the bottom, and the workspace area at the center of the screen. We decided to keep a similar design with SigmaNEST to make it faster for the users to gain confidence with it. So how can we interact with the 3D objects? First of all, from the Views menu, we can select quickly different views of the same part. We can also use the wheel if we prefer. The mouse wheel has 4 actions. The scroll zooms in and out. We can double click with the wheel to automatically get the auto scale done. We can keep the wheel pressed and then move the mouse wheel to rotate the object, or we can add the keyboard control button to the mix and pan the view. At any time, it is possible to change the selection options from here. We can select faces, edges, vertices, and the fill type as well, which can be changed to wireframe, useful to see the clean edges, or to the shaded representation we were looking at the beginning. Now I'm going to close the 3D view. And in the 4th chapter of this webinar, we'll see how to NC this part using the 3D Bevel engine. The first task we need to accomplish is setting up the 3D machine technology. We are going to do it just once per each machine. Let's get to the configuration dialog. And here, as you can see, there is plenty of different options and configurations to choose from. Typically, our technicians take care of setting up those parameters along with the machine post-processors. Also, one thing I'd like to mention is that it is possible to display each kind of machine head in 3D. Of course, we might need the drawing for it. After the general machine configuration is done, we can set up the rules we want SigmaNEST to use for the transitions, for the lead-ins, or for the feed rate ramping. This is pretty easy also for the user to set up. Let's take a look at the transitions, for instance. I'm going to the transitions rules and to the transitions list first. We're going to take a deeper look at the 2 more basic transitions, which are the line 5 steps triangle and the no corner loop 1. This one, the line 5 steps triangle, is the classic triangle. Basically, here the head will get out from the contour, it will reset its angle, then there will be a connection while cutting, and then the head will prepare the tilt, the rotor, the angle to approach the next contour. For each possible transition, it is possible to change all the properties of all the elements. For instance, I can change their dimensions. And as you can see, the graphic will display the modifications on the fly, but I can also change their properties like the allow tilt, the tangential, reverse, connector, start and end ones. This other transition here is the no corner loop 1. This one is intended, and in fact, as you can see, it is pretty clean, there are no blue entities. This transition is intended to obtain a completely no corner loop cut, a completely no corner loop transition. Basically, the head will perform its transition seamlessly without getting out of the contour. This provides a faster cutting and overall a better material yield. After the basic transitions will be set up, we will be able to assign them to rules. For instance, for the V2V bevels, SigmaNEST will prefer the no corner loop technology, while instead for all the other ones, it will stick to the line 5 steps triangle. Okay. Now, in the next fifth chapter of the webinar, I'm going to show you how to apply the toolpath on the parts based on these rules and how to play a bit with the manual interface as well. Let's auto and see the part. And let's turn on this new 3D interactive checkbox. SigmaNEST will show the part in 3D. It will be ready to apply the 3D bevel technology. To use the rules as defined, it's enough to apply the NC automatically. Let's quickly get to the simulation to check the path. Please note that I am using a water jet machine, a water jet head now, but the same technology applies also to plasma and laser bevel machines as well. As you can see here, SigmaNEST simulates the whole cutting path in 3D. An interesting feature at this point is that I can pause the simulation and click on the path wherever I want, and the simulation will automatically start showing that node specifically. This is helpful to concentrate on what's important. If we look at what happens here, we will see the power of the rules in action. As you can see, the transition from no bevel to V bevel is done with the triangle loop, while instead, for the V to V, the head tilts seamlessly from one entity to the other one. One thing I'd like to mention is that the 3D bevel capabilities provides an automatic result, but SigmaNEST allows the user to use the manual features as well. For instance, we can try to play a bit with the interface commands, and we can use the inner roll as an example. So let's get to the top view and let's stick to the hole. Okay. The first thing I'd like to focus on is the lead-in placement. The lead-in placement here for the straight and for the bevel passes is not too optimal. The lead-ins are very close to each other. Of course, I could change this result by modifying the rules. However, I want to take this as a chance to play a bit with the interface and apply a few manual modifications from here. The first action I'm going to do is moving the lead-in. So I'm getting to the leads, move lead-in function. As you can see in the tree view, I have different options. I can go for a free placement, snap to a midpoint, snap to the closest point. I will just leave the free placement here and click on the place I want to move my straight pass lead-in to. Then I'd also like to change the piercing type for the bevel pass. Since the straight pass will happen first, the material in the center will be prone to move or to fall down. So in this case, I'd like to shorten my lead-in a bit. I'd like to pierce at an angle and immediately start with a tilted orientation. So from the same menu, I can choose Edit Leads. SigmaNEST will highlight all the lead-ins and the lead-outs I can change on this part. I want to zoom on the area my lead-in lies. By clicking on the lead-in, I can quickly open its properties, and here I have a full control on all the entities. So let's say, for instance, that I want to remove the arc. Then I want to rotate this line back towards the center. So I'm setting an angle for it. Of course, I want to pierce in a tilted way. So let's allow the tilt on this entity. And let's maybe also shorten it a bit. Let's go for an 8mm lead-in. Once I'm done, I can press OK. And here, I can see it already from the node. It will be clearer later on in the simulation. Now I am piercing at an angle, and I am approaching the contour directly. We can quickly take a look at the simulation to see what is going to happen on this contour. the straight pass first, and then pierce at an angle and the bevel pass. We can also add tabs if we need them. Let's get to the top view again, zoom in a bit, and let's work on the tabs to keep the inside contour nicely attached to the part. I'm going to add a tab. Let's make it a little bit bigger so we can see it very easily. I don't want to use any rule, so no lead out. Let's add a custom lead in of 10 millimeters. Sorry. Okay. And now I can click on the geometry to apply my tabs. Okay. Now, let's try to look at how we can change the transitions on this part. Of course, doing the transition is great, but I could prefer using a no corner loop strategy also for this kind of transitions here. I'm going to get to the top view again, and then I'm using the edit transition feature. SigmaNEST will highlight in orange this time all the possible transitions I have, both the no corner loop ones or the triangle ones as well. I can select one or both, and here I can quickly change the transition type to a no corner loop one. Let's apply it and let's press OK. I'm going to simulate the path now to see what happened with my modifications. Let's start from the first loop. You see that the head will do the straight pass first with the tabs. Then it will pierce at an angle and cut the hole. I can speed up a bit here. Then the blind bevel. And here the head will tilt and produce an overall no corner loop cut. Please notice that here the head will tilt seamlessly on all the part's edge. Now, though this kind of approach might be great for a water jet, it might not be very optimal on a plasma machine. We can automatically change the rule in order to get a breakpoint at a certain distance from each edge. But just to play a bit more with the interface, we can even add it manually from here. In this case, I'm going to use the break edge command. I want to break the edge at a selected point, and I want to break it here. If I simulate the same NC path now, as you can see, we can start from here. As soon as the head will get to the breakpoint, it will get back to 0 degree very quickly. This is typically preferable on a plasma or on a laser machine. Now, there is plenty of other features we can use in our 3D bevel engine. They can be really automatic through the usage of rules, or very manual through the total path control our interface provides. As a final result, we can close this dialog, get back to the part mode. We can, of course, resave our part with a pre-NC on for later usages, and we can then process with the SigmaNEST standard flow, which consists in creating a task, adding this part, and maybe other parts as well, and calculate the nest. I'm going to stick with the manual nesting this time, because I want to show you how SigmaNEST automatically takes care, and you can see it by looking at the spikes on the bottom edge, how it automatically takes care of calculating the bump on the real part extensions based on the NC. I will fill the sheet manually for this time with just a couple columns of this part. Then on the nesting and C, I'm going to apply a toolpath on the whole nest. The toolpath will, of course, mimic the sequence and the manual operations done on each part. And then I am going to simulate the full nest toolpath using the 3D view. Here, I will be able to look at the complete nesting simulation with all the machine and the head motions in the 3D environment as well. Okay, I hope I've been able to give you a good display of our new 3D bevel functionalities for SigmaNEST V20. Thank you for your time.
Thank you, Diego. SigmaNEST has become a brand in the sheet metal fabrication, and as such was recognized by many large multinational companies such as John Deere, Airbus, Boeing, and many others. So thank you for your attention, and we'll see each other in the next webinar.
Thank you.
Bye.